Hi, welcome my friends. We're going to talk a little bit about the Bouncy Lab and some of the data analysis here. So bear with me. I'm going to run you through 3 examples of how to calculate forces, and then we'll talk just kind of in general about some of the things that are happening during the lab and some of the things I want you to take away from it. So to start with, we can notice the trend in our acceleration starts out positive, becomes less positive, it hits 0 right about here somewhere. And it's interesting to note that that's like right after my feet leave the ground. And then also down here, then it becomes negative acceleration, negative, 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 and then up here becomes positive again and becomes more and more positive. Right? And we also know that whenever there's a positive acceleration, it means that there's an upwards force, and there's a negative acceleration, a downward force. That might be worth writing down. So anytime that we have a negative A, that's going to lead us to the conclusion that there is an upward net force. And anytime, that should be anytime there's a positive acceleration. And anytime there's a negative acceleration, that leads us to the conclusion that there should be a overall downward net force, right? So that'll be really good to know. So here, when this is in this region of the graph, and we have positive accelerations, that means there must be more upward force than the weight of my weight, which is the downward force. And here, during this part of the graph, means that my weight is greater than the upward force, so there's a net negative downward force. So all through here, and here the spring gets so stretched again that it's able to pull on me harder than my weight's pulling down, and I start getting positive accelerations. And notice here I get large positive accelerations where my feet get involved. I'm actually pushing up with my feet as well, helping the spring. So both me and the spring are pulling harder than the earth is pulling me down, and I get an overall positive acceleration. Now notice there's 2 possibilities for positive acceleration like we were talking about, right? So positive acceleration here can mean that I'm speeding up upward. That's what's happening here. I'm speeding it up upward. And then this positive acceleration, I'm falling, so I'm slowing down downward. Right? And those are 2 weird interpretations. So a positive acceleration could be speeding up or slowing down. Okay? Now this next one, so when there's a negative acceleration, there must be a net force downward. And in this case, the spring, when I'm at the top here, the spring is becoming unpulled, right? There's less tension on the spring. So there's less force pulling me up, and there's more weight. My weight is bigger than the upward force. So I get a net negative force, and I'm either, so right here, as it goes negative here, you can notice as I go up, I go from going really, really fast, I'm slowing down. So this negative acceleration can mean I'm slowing down upwards, or from here, speeding up downward. So those 2 things real quick, and maybe we just write those down. So for positive acceleration is upward net force, I can either be speeding up, sorry, let me erase that. There are 2 possibilities. I can be either speeding up, or I could be slowing down. Okay. And these 2 go right there. And then for a negative acceleration, I can either be speeding up, down, or I can be slowing down when I'm going up. Those are the 2 possibilities for a negative acceleration. Okay. All right, with that handled, let's deal with how we do some of the math here. So one of the key things to note, I'm going to erase this on the screen, so if you need it, hit pause. One of the key things to note here is that when I'm not touching the ground, when my feet aren't on the ground, there's 2 forces acting on me. There is the downward force of gravity, which we can find by just taking the mass times acceleration of gravity, right? And there is the upward force of the spring. And those are the only 2 substantial forces acting on me. So when this is the situation, we say, hey, our net force is equal to F sub g plus F spring. So the sum of the forces give us the net force. Now with that in mind, we have to remember that F sub g is a downward force. So the number we're going to put in here is going to be a negative number always. So F sub g will always be a negative number. And the spring only pulls up, so it's always going to be a positive number. And then whichever one is bigger will determine whether this is a negative or positive net force. Okay. So let's do some of that work real quick. Before we get into this equation though, let's calculate my F sub g. So I'm going to come over here and say, all right, my F sub g is equal to my mass times acceleration of gravity. Now, my mass I have to know, and I do know it, and it's 110 kilograms. And that's times 9.81 meters per second. And I didn't cheat and use 10 because we're doing actual data. So I want to use the correct stuff. So I take 110 times 9.81, and I get 1,079. F sub g is 1,079, and the units are kilogram meters per second, and we know all of this is called a Newton, so I'm just going to erase that real quick and write in a Newton instead. That's what we call a Newton. Okay. So this is my F sub g, so this force is constant. The Earth doesn't know where I am, it's always pulling with 1,079 newtons. Well, as long as I'm near the surface, I guess. And now we can use this force over here. We have this number always now. And I'm actually going to do a couple things here. I was a little sloppy. This is a negative from gravity, and this is a negative as well. The force of gravity pulls downward, so it's a negative force. And that's due to the negative acceleration of gravity. All right, so that's done. We know F sub g. Now we need to figure out what the net force is to find the spring force. That's our goal, is to find this, how much is the spring pulling on us. So if we look over here at the net force, and I click back to right here, here's our biggest positive acceleration. Now this one we can't actually calculate the spring force on, because not only, let me erase this real quick, because the spring's not the only thing pulling me up, it's also my feet pulling me up, right? So in this case, the net force would be, let's draw it real fast. It would be the force of me pushing up, right? And that's actually the force of the floor pushing me up because I'm pushing the floor down. And then there's the F sub g and the F of the spring. So that the net force is my force of gravity and force of the spring all added together, with the F sub g being a negative number and these two being positive numbers. The problem is it's hard to pull this F sub me out so we can find the force of the spring. We could do it with some math, with some extra effort, but we're not going to do that. We're going to focus more on other parts of the jump when the floor isn't involved, because I won't be touching it. So let's look like right here where the acceleration is 0. So at this point, I know my acceleration is 0 because I can just come over here and I can say, okay, this is the acceleration thing. So wherever it's 0 is right here where it crosses the line. And it's going to be right around in here somewhere. I'm a little bit off, but pretty close. And you can see my feet aren't touching the ground. So here when the acceleration is 0, that leads us to the conclusion that the net force must also be 0, and that the forces are balanced. So those is an important conclusion to come to an A equals 0. That means that the force of my weight, F sub g, is equal to the force of the spring. So F sub g is equal to F sub s. Now they're equal in magnitude and opposite in sign, right? So the spring is a positive number, F sub g is a negative number. So in this case, the force of the spring at this point, so the force of the spring is equal to a positive 1,079 newtons. So far so good. Now that happens again, that's true right over here. So let's add that. So right here where the acceleration is 0 again, which should be really close to right there, the force of the spring is 1,079 newtons. All right, so let's zoom forward a little bit and see if we can't figure out what that spring force is in the middle of the high point here. So right here, and you can notice that my curve is a little weird here. There's this little hitch, and that's from me doing a scissor kick there. It kind of throws off some of what's happening. But we'll take this as being the most negative point. Yours will likely be right in the middle somewhere. And you can see, all right, let's do this. This is a good point to do. So let's find our force of the spring. Here, there's two forces acting on me. There's F sub g, and there is F of the spring. And now my acceleration is negative, so that means my net force has to be a downward net force, which means F sub g must be bigger than force of the spring. So we can write that here. F sub g is greater than F sub s of the spring, because there's more down than there is up because I got a negative acceleration. But bigger than, we want to actually know what the numbers are, right? So right now we have one of the numbers. We have F sub g. We have this one. And to find force of the spring, we need to know the net force. And we can figure that out from our acceleration. So let's draw a line here and say, okay, so we know that our net force is equal to the mass of the object times its acceleration. And in this case, my acceleration isn't 9.81, it's this. And it's not the full 9.81 because there's a spring taking away some of my weight. So I'm not accelerating as fast as I should be down because the spring is counteracting some of that force of gravity. So when we do this, we say, okay, so the net force is equal to mass, 110 kilograms, times a negative 6.982 meters per second. And when we do this mass, or this math, we find that 110 times 6.982 gives us a net force of 768 newtons, right? And because this is negative, this is also negative. So that tells us our net force is downward, which is not surprising because our acceleration is downward, right? So our F sub g has to be bigger than the F of the spring. To find it numerically, we say here's our net force. And that number is a negative 768 newtons is equal to F sub g, which is a negative 1,079 newtons, and then plus F of the spring. Now all I have to do is just solve this. So I just add this to both sides. And when I take 768 negative, and I add to that 1,079, I get that the force of the spring is equal to 310 newtons. It should be right around 311, I apologize. So does that make sense? So first we found our weight, and we can do that right away because the weight's going to be the same the whole time. And then based on the acceleration at that point, here's my acceleration down here, negative 6.92. I use this acceleration with my mass to find what the net force is. And then once I know the F sub g, this one, and the net force here, I can simply just do some really simple arithmetic to find the force of the spring. And that's how much force is pushing up. And you can do that at lots of different points. So at this point, let's do that right now. The force of the spring is equal to 310 newtons. And that makes sense because the string is minimally stretched right now. When I'm falling down, the spring is more stretched, so there's more tension in it. And if I were to calculate the spring up here, if I could, with removing my feet, how hard I'm pushing, I'd find that the force of the spring got bigger and bigger and bigger as I went farther and farther and farther down. Right? So those are the main calculations you're doing here. So you're going to have to find the net force F sub g, and you know the sum of these two is equal to the net force. Bam, you're good. All right, I hope that helped. There's a few other things to note here. One is that my positive acceleration could exceed 9.81, the magnitude of the gravity, because the spring and I'm pushing together, so you can get this much larger push. And then down here, I can't get more than negative 9.81. Because if I were to jump to the point where the spring actually was fully compressed and wasn't pulling me up anymore, gravity would be the only force left, and it would cause an acceleration of 9.81. So here, even if I had jumped as high as I could possibly jump, the most I could get here for negative acceleration is 9.81, that which is due to gravity. Well, I hope that helped, and I hope that clarified some of the calculations you had to do. If you need more help, I'll talk to you in class about it. Have a good day, my friends.